Hello there, everyone. My name is Vandal. I'm a solution architect here at Core. It's a pleasure to be here talking with you today. So, for those of who might not know, Core is a technology consulting and development service provider that help companies to innovate, scale, and transform. Today, I'm happy to share a little bit of Core expertise with technology solutions and methodologies and drive you through a little bit of our cloud solutions offer. So, let me start sharing my screen and can dig deeper into that. So, as I said, usually cloud solutions help you to keep the pace with digital transformation. And we are going one specific part of that offer that is going to be app modernization. So, app modernization is going to help to support your business needs in an efficient and cost-effective way. So, first of all, talk a little bit about me. As I said, I'm Vando. I'm a solution architect here at Ecor. I've been working as a consultant and working with two implementations, practices, and process improvements. I have a background in software analysis and development, and also I'm postgraduated in project management by University of São Paulo. I have also a few certifications on Scaled Agile Framework and Atlassian, and going to be talking a little bit here today with the guys about app modernization. So when you're talking about app modernization, usually it's related to a transformation. So usually when we talk about transformation, we have three main pillars that undergo a transformation altogether. We have the people, the process, and also the technology. When we talk about people, usually is related to the culture, the communication, and how the organization can optimize their structure. Talking about process, and mainly when you're talking about cloud solutions, it's how the organization and all the areas of the organization are going to consume the cloud capabilities that can be provided with cloud evolution. And when we're talking about technology, we're talking about the platform that's going to support the people and the process. So when you're going through a transformation, there are a few areas that which be involved and should be involved and usually are involved. So when I talk about people and structure, this is mainly related to the organization itself, the leadership, and also the employees. And when I talk about the technology and the process, it's related to the architecture, infrastructure, and also the delivery. So in the past, we usually use it to see organization more organized toward the activities and how the activities were delivered, and the leadership were more autocratic, and also the team they tend to be more order takers. On the architecture side, we use it to see monolithic applications, so everything being structured just one single application, infrastructure usually being on premises, and the delivery being made and planned through waterfall process and being delivered throughout tasks. On the second column we have here, it's where we see most of organizations are nowadays. So organizations are more structured toward functions. The leadership tends to be more democratic, with more participation of everyone, and also the employees being more participant, being involved throughout all the process. The architecture is more service-oriented architecture, and the communication is usually XML-based communication. And then the infrastructure is based on virtual machines. Those virtual machines can be either, still being on premises, being created on on-premise environment, or could already be on cloud, but using virtual machines, not leveraging all the functionalities and all the advantages that cloud could bring, and the delivery being made throughout agile process and being delivered throughout projects. So when you're talking about app modernization and this transformation, usually is this transformation, this path from the second to the third column. So organizations start to be not more completely organized on functions, but being organized on teams. The leaders, they are not just more democratic, but start being servant leaders. The people and the employees, they tend to stop to be not exactly stop to be participant, but they tend to be more not just a participant in the process, but more problem solvers. When I talk about the infrastructure, when I talk about the architecture, it moves from a service-oriented architecture and start to be more organized and more architecture toward microservices. So more on REST-based communication and that kind of stuff. All the services being responsible and being owned by one team, and each team takes the responsibility of that small part of the process and of the one microservices. On the infrastructure side, we see V2C, that's what we call, from a virtual machines to a cloud environment, and starts to leverage all the functionalities that cloud may bring, so containerization, breaking that down into microservices. And then on the delivery, we see DevOps, continuous implementation, continuous delivery pipelines, and also service reliability engineers. So focus on the on shift and left and all the security that's being involved, and the deliveries being more focused not just in projects or text, but outcomes that it's going to bring, all the value that's going to be bringing to the customer. So in a nutshell, application modernization is the process of updating existing legacy application or building entirely new ones to better align with the business objectives of the organization. So there are many paths that we can follow. I was focusing on the goal, as I said, on the outcomes that is going to bring on our advantages. And usually the path that we take is we start with the discover phase. So we can discover, understand, assess, and prioritize all the organization's needs. And based on that, we can create a migration plan, a migration path for the one applications or the applications that we are going to be working through that transformation. So two options there exist after we determine, after we understand, discover, and assess that. It's for applications that are outdated, are not going to be used anymore. There are two options we can retain. That's going to be not moving the application to cloud, not modernize the application, or even retire and decommission the application. If the application does not more bring in the value, it's going to, it was already going to be decommissioned. That's one option. And when you're talking about the modernization, the application, there are usually four paths, four options that we can have for that. The first one is going to be rehosting, that being lift and shift. So we basically just grab the application, the same way that's working, the same way that's structured, the same way there's architecture on the on-premise services, and move that into a cloud server, into a cloud virtual machine. Even though it's just a simple move, it's just a simple solution, we can start leveraging some cloud functionalities. I'm going to bring you guys a little example, and we can see which functionalities with how we can leverage and how we can already see good outcomes on that. Other option would be replatforming, that being lift and reshape, that being we can grab the application and just change a few lines of codes or change the development language, the language that was developed, and then move to the cloud this way. Other option, if it's a third-party application, is something that is not owned by the organization. It's going to be repurchased, that being drop and shoppers, that being just recontract the application or move from an on-premises installation to a cloud. For example, Atlassian applications, move from the on-premise application, the on-prem installation, make a migration to the cloud versions. And the last option, that usually the ones that bring more advantage, that we can, leverage more the value of the cloud, is going to be refactoring, that being rewriting the entire application and decoupling the applications. If we have several services in one monolithic application, decouple that into microservices. And one thing that I'd like to bring does not to be made in a big bang move. It just have to be made all at once. We can break down, we can use several strategies on that path to refactor the application. After that is made, we validate, would be the validation either with the organization, with the customer, and then move that to production to make sure everything it's aligned with the organization needs, everything's aligned with what's being planned. So on that matter, how we usually do that, or how we start engagement model to help the organizations, to help our customers to do that. So our cloud app modernization offer, as we can see here, usually we have customers that are bringing either with monolithic legacy applications, and then we go through a discover phase. In the discover phase, we're going to mainly understand the context, to understand which the application, which the needs of the organization, how we can help that, and also to make a legacy modernization plan. Usually that's going to take, from 2 to 4 weeks. It's depending on time frame, depending on the site application, depending on complexity also the application. And then after we make the discovery for each one of the applications, we start with an engineering process that's going to be made throughout an agile delivery, that we can either refactor, rehost, or decide on which path we're going to follow with this application. And then that's made with a continuous delivery process. And then we can go through several apps, that cloud app number one, number two, and how many apps is needed for that migration. So digging a little deeper into discovery phase and how we do that, we have a cross team that is who makes this discovery phase and is responsible for understanding the application that needs to be migration, how we can do the migration, also to estimate the effort that's need to move that to the cloud and to validate this understanding with the customer, because uh, either way we can on the same side, we need to understand, we need to make this migration path, but also validate with the customer, validate with the organization if it's a path they're willing to follow, how long it's going to take, what's the size of the effort on that. And also this squad is also responsible for monitoring the progress when we are on the engineering phase also, and to help the engineering teams by removing the blockers, and also any dependencies and any kind of blocker that might appear. Is composed by the pre-sales team, a project manager, a solution architect, and also a product owner. When you are in the engineering phase, the squad is basically composed by developers, so we can have, depending on the size of the application and the complex application, we have from 2 to 5 developers. And then this engineering team is going to be responsible for executing the modernization itself of the application. So, as well as make sure that runs perfectly in the design environment. So make sure everything is one as we planned it. You do not have, any lack of functionalities that we have that we are going to migrate to cloud. And then they work alongside with the cross team to make sure there's a clear understanding of the work that needs to be done. So the cross team came in, made the understanding, make all the planning, made all the architecture of the application, and then they're going to make this handover to the engineering team to make sure there's a clear understanding of what needs to be done. And also for a better scalability of all this process, we can have one cross team that's going to be the team that makes discover, that can be work up to 5 engineering teams. What means? So we can have, for example, the first application to be modernization. The cross team is going to be engaged on discovering the application, understanding how it works, and make the migration path, and then make this handover to the first development team. After developing team, the engineering teams are already working, then the cross team can engage to another application to make the understanding. So we can parallelize the activities and have, as I said, one cross team working with up to 4 development teams. And all this process is made throughout an agile delivery. So we understand the project requirements. Based on the requirements, we're going to create a product backlog. That product backlog is going to be prioritized into sprints, into a prioritized backlog, and make the planning, move that to the sprint backlog, go throughout the iterations, basically the full Scrum and Agile delivery process. And then, of course, by the end of each deliverable, we are going to validate to make sure that all deliverables are achieving the outcomes that we need and that we planned. And on that matter, I like to bring, just a little example, kind of a little demo on how we could make a modernization of one application using Google Cloud Run, through all the path that we can make, all the steps we could follow to get to the optimum place. So for this scenario, I'm going to bring an example of an application that fetches news articles from various sources and displays that to a front-end page. Of course, going to be started with the monolithic application, is an IIS on Windows Server. It was built based on ASP.NET and is basically composed of 3 services. One is the reader, that which fetches the RS feeds. Second is the transformer that converts to a common format, and the web API that serves that to a public API. So the MVP, so the first phase of the application, as I said, is an ASP.NET application that is on IIS row hosting. And for MVP, that could serve well, because it's not expensive and it's easy to understand and easy to make the deployment. But in the downside, there's much coupling to the application, as is a monolithic application. We have all the 3 services just inside one application. We do not have a good experience for the developer, because if the developer needs to check through the logs or all the good stuff, they will have to FTP into the IIS server to get this information. And also on this scenario, still there's not redundancy, still there's not persistence or resiliency of the application. So if we see a huge volume, for example, the application might stop working, and then to troubleshoot that, the developer would have to FTP into the server to get the logs, to get information to see how and why the application has stopped working. It's not a good developer experience, but as I said, for a first validation, for a minimal viable product, it could address, so we can start validation. The first step that we could do that to improve, it would be rehosting the application. So uh, one option would be rehosting to Google Compute Engine. Google Compute Engine is nothing more than GCP virtual machines. So we could create an instance VM to autoscale and use metrics to outscale, and then basically it would be easy to move that to the cloud. It would be basically just a lift and shift, and by that we could start leveraging some advantages of that being cloud, and we could uh, use a load balancing to also have the possibility of outscaling a better developer experience with stack driving logging. For example, we could also take VM snapshots, and then for when you have an issue, we need to check the log. The developers could easily RDP into the servers to get information. So as I said, the good side is going to be easy to move. We can start having redundancy and also use load balancing. But on the downside, instead of having one server that shares the applications with other applications, we would have to have dedicated virtual machines to run the application. That would be a little bit more expensive, and also besides the cost of the virtual machines, we have the cost of the load balancer. But there's a few advantages and a few downsides on that. And to improve that, our next step could be, for example, replatforming that application. So, as I said, it was originally working as .NET, and then we could, change that to rewrite the application in .NET Core, and then we could start containerizing the application and deploy to App Engine Flex. So, as .NET Core, for example, it runs on multiple platforms, so we will not be dependent on Windows platform. And then with App Engine, everything's bundled together. One other option could be, for example, run it in a Kubernetes, but kind of be too much for this simple solution. So App Engine would suffice and address all the needs that you have. So with that in mind, after moving the application from the previous language to ASP.NET.Core, we could move to an App Engine Flex that's going to be hosted on a Linux server, a Linux virtual machine, and then we will not have the license fee for Windows. Also, easily and more outscaling, so you can automatically outscale that. Not based on any parameters you need to configure. It'll be more easier and easy to do. And also traffic splitting, for example, there's another functionality that App Engine brings. But on the downside, we will still be paying for the VMs, even though App Engine is a containerized environment. It's still, on its guts, it's a virtual machine, so we still pay that for a second that's being used. If you had application not being too much used throughout the night, we still be paying for that. And even though we had improvements, it still slow deploy, so it will take from 5 to 10 minutes to bring each container on that. To improve that, we could make another replatform, for example. So we could, moving that from App Engine to Cloud Run. So Cloud Run brings some serverless features to containers. So a few of use cases of functionalities that Cloud Run brings is to have public and private endpoints that would work well with our applications. And also, one big advantage in that is the billing time. It's just the time their requests are being handled. So that being said, we will not be billed anymore, by all the time that the virtual machine is running, but just for the time that our application is handling the request. So just update from a new version 2 of .core and .NET Core and deploy that to Cloud Run with just one command. It's as simple as that. So as I said, a few advantages of that: we would have serverless billing and increase the dev experience, to way faster deployments and all that kind of stuff. But on the downside, our application is still monolithic. So which are the monolithic issues that we see on this moment? So when you have to scale, we can either scale all or nothing. For example, if we need to scale the web front end, that we're having more users, more requests, the reader and the transformer are going to have to be scaled as well. So it's not the ideal scenario. Also, we would have a cold start. So for example, if the application was not running throughout the night, when you have the first request, the first customer to make a request, as we have no persistency, the application would have to fetch the feeds and then move that to the transformer and then serve the first user. So the first user would have to wait for a while to start using the application. And also, there's no way to update the services. So many times, if there's need to update the transformer, to read from a new SS feed, and then to update the transformer to read the new format of the SS feed to serve that on the common format that we're serving. Instead of just updating the transformer, we have to update the entire application. So the next step, and a good step to do that, would be making the refactor of the application. So with that, we can leverage all the functionalities that GCP brings, and then here's kind of the architecture that can be used to that. So you have a cloud scheduler that is going to be scheduled, in any time from in 1 2 to 2 hours, that calls the reader. Then the reader goes and reads and fetches all their SS feeds and get those informations and saves to cloud storage. That's basically an object storage. With that in mind, after we have that, we could have notifications to a pub sub top key and serve the transformer. So what's going to happen is the transformer is going to convert that to a common format and save that into Firestore. Firestore is a NoSQL database, perfect for the JSON format data that we have here. And then with that saved in CloudStor, when have requests from the public API from the customer, the public API can consume that information from CloudStor. So we see here several improvements, and also breaking down all the applications that we have, those 3 services that we have in just one application. We broke that into different Cloud Run containers and 2 different Cloud Run services, so they can run independently. So a few advantages that I have to that: we can have an asynchronous communication. We will not have just the updates that when we need information, everything is saved in the cloud-based Firestore after it has been transformed and after it has been read by the reader. Also, if we need to scale any service, so as I brought in the previous scenario, if we need, for example, we have a huge volume of customers on the web API, we need to scale, we can scale just the web API without need to scale alongside the transformer and also the reader. And also, we can make individual updates on that. So, as I said, if we are going to be fetching information from a new RSS feed, and we need to make a different transformation that we can update just the transformer and make the deployments and make the changes just on that. So this will be the last step. It would be a good scenario, but a few lessons learned that I have on that, and how we can learn and how we can understand. First of all, the transformation doesn't have to be all or nothing. It does have to be a big bang transformation. So we can take small steps into transformation. We can bring and understand which the current scenario of the organization and where we want to go. And with that in mind, to develop small steps, to evolution steps, and we can iterate throughout those and to bring advantage. So even though we can start using, for example, non-optimum to optimum solutions, like we saw here in the first example, the first thing that we do was to make a rehosting, just basically moving a lift and shift of the application from the on-premises to the cloud. Even though it was not the optimal solutions, we could already see some huge benefits, as we saw in this example. We could see, and improve some on the availability of application. We are already using load balance and all that kind of stuff. But we have also to keep in mind that at some point, refactoring is going to be needed, and the composition of the application could be hard, because on the first moment that the application was thought and was architectured, it might not be architecture thinking on those microservices. And sometimes it's where you can, throughout all the path, you need a partner to help you, so you do not overload your support teams, your teams that are working on a day-by-day basis in application, with all that, besides the work they're already working with those new projects and those new the composition of the services, those new architectures. And that's where a partner like Core can help you to do that. So as I said, great ideas start with conversation. And if you need information, here are my contacts. If you can reach out to me, and we can talk a little bit more about this app modernization and how Core can help you with that. So if you're interested in learning more about how cloud solutions can help your organization, feel free to set up a 30-minute conversation and consultation to speak with one of our associates and to see how Core can help you to transform, build, scale, and sustain your organization. And I hope this demo and this presentation was valuable and useful to your business. Stay tuned for more valuable content. Follow us on social media, on LinkedIn, Instagram, and also take a look on our website when having a chance to see all the offers that we have and how all the ways that can help you, your organization. So once again, thank you so much for your time and attention, and take care.